The purpose of this video is to explain to you metric conversions using dimensional analysis. You will be able to use table 1.2 in your book on page 6, and the method we're going to use is similar to the method we used earlier with dimensional analysis. The only difference is now we're converting from one metric unit to another metric unit. So the first thing is to look at table 1.2, and I'll explain the table a little bit. It looks slightly different from the one in your book. In here, I've included deca and hecto. Those are not in your book. All right, so how to read this table. If you look in this column, this is the prefix of the metric unit. That's going to explain to you basically the number you need to multiply by the base unit. Here is the symbol for the metric prefix. In this section, this is the multiplier times the base unit. So for example, 1 decameter would be 10 of the base unit, so 10 meters. Scientific notation, this is the number written in scientific notation. For example, if you look at deci, it's 0.1. In other words, 1 times 10 to the negative first. And then in this last column are examples of metric prefixes attached to their base unit. In this first example, I'm going to be converting 3 kilometers to meters using dimensional analysis. So just like in the past, you start with what you know. So I have 3 kilometers. I have to multiply by a conversion factor. So if we were to go back and look at table 1.2, you would see that there is a conversion factor that would show you in 1 kilometer there are 1,000 meters. We're going to use this for our conversion factor. We know that the kilometers need to cancel, so I'm going to put kilometers in the denominator. And I'm converting to meters, so I put that on top. Looking at my conversion factor, I put a 1 with kilometers, a 1,000 with meters, and then all I'm left to do is I can cross off the units. I'm left with meters, so I have 3,000 meters. In scientific notation, that would be 3 times 10 to the third meters. In this next example, we're going to be now going from 3 kilometers. We're going to go past the base unit or the fundamental unit all the way to centimeters. The way I would suggest doing this is you convert from kilometers first, then go to the base unit, which is meters, and then go to the unit you're trying to convert to. Here's what this would look like. Once again, we start with what we know, 3 kilometers, multiply by a conversion factor. I need kilometers to cancel out. I'm going to go back to the fundamental unit as I suggested. I know in 1 kilometer there are 1,000 meters. And now I need another conversion factor. And looking at this, I want to make sure I cancel out meters, so I'm going to put meters in the denominator. Meters, top, centimeters, which is what I'm converting to. Looking back at the table 1.2, I know that in 1 meter there are 100 centimeters. Let me shrink this a little so I can fit it. Now all I'm left to do is the math. I know kilometers I'm going to cancel out, meters I'm going to cancel out. So 3 times 1,000 times 100 ends up being 300,000. In other words, in scientific notation, it would be 3 times 10 to the 5th centimeters. You always want to make sure you include the units within the dimensional analysis work itself, and also units on the end. It's extremely important. Okay, so what we've done so far is we've converted from kilo to meters, and then we went from kilo to centimeters. So we went this way. What we're going to do now is convert, and we're going to start with centimeters and convert to hectometers. Now what you'll notice is over here, next to centi, we have a negative exponent. The method I'm going to show you will explain to you how to always use a number in scientific notation so that you end up with a positive exponent. And I'll explain what I mean by a positive exponent always. Once again, we're going to start with what we know, 6 centimeters multiplied by a conversion factor. We're trying to get rid of centimeters. Remember, always go back to the fundamental unit. And what I'm going to do now is, you noticed before when I showed you centimeters that the exponent was negative. The multiplier 10 to the negative second. The way around that is, if you look at your conversion factor here and you ask yourself a question, okay, which dimension is larger, meter or centimeter? A meter is larger than a centimeter, so the larger dimension gets the 1. What that's going to do is the other dimension is going to have a lot of pieces to it in order to make up the larger dimension. So same thing here. I want meters to cancel out. I want to end up with hectometers. I ask myself the question, which is larger, a hectometer or a meter? A hectometer is larger, so I'll put a 1 up there. And I look back at my table and I would realize that in 1 hectometer I have 100 meters. Let me shrink this, get it to the side. So now I'm just left for the math. Double check, my centimeters cancel out, meters cancel out, I'm left with hectometers. I'd get 6 in the numerator, and I would get 10,000 in the denominator. Making that in a decimal format, it'd be 0.0006 hectometers. Sorry, I ran off there a little bit. Writing that in scientific notation, it would be 6 times 10 to the negative 4th hectometers. And finally, just to review, a couple suggestions to the method I just showed you. You want to make sure that you are starting with what you know, and then once you start the conversion, convert to the base unit first, and then convert to the unit you're trying to get to. Ask yourself the question, which one has the larger dimension, and place a 1 with it. That'll alleviate the need for a negative exponent. Then check for units throughout your work and your final answer. And then finally, just double check your work. Thanks for watching.